Right, so they've already introduced kind of the fledgling starting of what was how did we end up with essentially what 4 and a bit projects now in OSC focusing on SMO. Back in the very early days, we kind of assumed that there was some kind of a thing up there that did some kind of intelligence, and drew a box around that, call it a non-real-time RIC. And OSC decided to need a project for that. And somehow I got volunteered to be the PTL for that. As we went on then, the concept of what is a non-real-time RIC and how are we going to actually define what this is, how does it fit into the larger concept of an SMO, what's the difference between an SMO and a non-real-time RIC. So we're still arguing over that. So in OSC, at least, we have a good cooperation, a kind of a family of projects working in the SMO space. My one is NONRTRIC, and I have the pleasure and honour of being the PTL of that project. So I'm going to very briefly skim over a couple of topics, and then I'm going to hand over to Aravindhan here, who's going to show you a couple of very brief demos, mainly just to pique your interest, to kick off conversations out in the hall or later during the week. So we expect to be a little bit confused when I'm finished. That's the idea. I want you to come talk to me afterwards, okay? So mainly for the sake of reference, I threw up too many references here for you to read. But currently we have, in the non-real-time RIC project, we have 18 different repos of different functions that we're kind of demonstrating, at least trying to show kind of proof of concept implementations or very early kind of demonstrator functions within the non-real-time RIC, or support functions for that. Okay, so within that, follow the links, basically. Right? So I want to show this overly complicated architecture picture, again, which I'm not expecting you to digest, but it's here for reference. But in terms of some of the areas that we're looking at, the non-real-time RIC originally started off, like I said, it was a blob that does something intelligent, and then moved from that to, okay, maybe we should terminate the A1 interface in there. So the early days of the non-real-time RIC, we were focusing on implementing the northbound of the A1 interface, particularly in a controller for A1 policies, A1 enrichment information. Pretty quickly we realized that having a blob of non-real-time RIC was probably not a good idea, and we should introduce the concept of apps and pluggable logic. So then we decided, well, maybe those apps should be multi-vendor. Why not? So we need to define a standardized interface then between our apps and the rest of the non-real-time RIC and the SMO, which then, after some challenging naming discussions, we went with the R1 interface as the name for that interface between the our apps and the rest of the platform. So fairly quickly, our focus in non-real-time RIC moved from the fairly stable A1 interface to what do we need to do to support our apps? How are we going to start chipping away at this massive problem that is the R1 interface? So some of the areas that very quickly dropped out was that an RApp must be a self-contained thing. It must produce and consume data, and must produce and consume services. So they were kind of 3 areas that we could jump on straight away. So we are going to focus on, just in today, service management, which is the service exposure and the service consumption by kind of a sandboxed RApp. Also, the RApp management itself. So an RApp has to be onboarded, it has to be lifecycle managed, it has to be basically sandboxed and controlled, and access to services, production of services, access to data, production of data has to be tightly controlled. So that's the concept of RApp management. And again, we're going to show some scrolling text to try pique your interest in that area, and then come talk to me then about exactly what it is that we're doing in those areas. We've also dipped our toe in many different areas as well around data management and exposure, A1 policy functions that I mentioned earlier. How do we produce and consume data? So adapters for mapping, for instance, OEM data to R1 data. What else have we got here? We did a deep dive on actually gathering PM data from a RAN and producing it in a way that it's consumable by our apps. We have a simulator for the A1 interface, and a bunch of other kind of supporting functions there on the left-hand side. Okay, so our priorities now, right this release, what we're focusing on now, is on service management and exposure and rApp management. And then maintaining, or in some cases maybe needing to scale down and maybe archive some of the older support functions as we have a better understanding of what those support functions need, and also shows where we need to focus our resources on. Right now, we're focusing on service management and exposure for R1 and rApp management. So the ORAN Alliance in Workgroup 2 have focused on the 3GPP CAPIF family of specifications as a good way for exposing and discovering services to and from rApp. So we've implemented a CAPIF implementation of a service manager, and then shown that all access to and from these services should go through some kind of an API gateway to give us an enforcement point to control the exposure and enforce the exposure of services to and from the rApps. Again, we have a quick demo on this in a few minutes. Then rApps themselves, the concept of rApp actually really isn't very well defined at all. We just know that it's a yoke somehow that's fairly self-contained, and all interfaces to and from it should be standardized. That's kind of about as far as we got with rApps at this stage. We do know that there's an R1 interface. We do know that a key part of the R1 interface is controlling the data and service access to and from rApps. And then the rApps themselves need an rApp manager to enforce the data management and the service management. Okay? But in addition to that, something that I'm going to focus on in a little bit during the demos, you'll see there's a particular area that we want to focus on as part of rApps. Okay? And then I say the maintaining the A1 policy functions as well. They're stable, but they need to be supported and maintained as we go along. So that's our main priorities right now. So I'm at this stage that I've bamboozled you enough, I think, at this stage already. I'm going to hand over to Aravindhan, who's going to show you a very, very quick feeler for the work that we're doing around service management and exposure in this release. So please, Aravindhan, will you take over? Just hop it up there on top. Sorry, throw it up. Can't. Okay, hop it down. Okay.
Hello. Hope I'm audible. So let's get onto the chase. Then I'll show up what the setup I have for the service manager right now.
Can you hear?
Can you hear me?
Okay, here.
Okay, right, yeah.
Here, take this one. Oh, it's working now, isn't it? Here.
So I'll go with the setup first. Just I'll show what I'm running here. So I'm running a NONRTRIC namespace in a Kubernetes where we could see the service manager pod is running along with the API gateway, which is a conch here, and the CAPIF core is running. So the service manager is kind of using a CAPIF core as a backend for that, and it integrates with the API gateway. And I'll show another thing right now. So there is a microservice running in this environment, which is called a Hello World deployment, which actually exposes a certain kind of couple of APIs there. And the service manager is going to expose these APIs right now. So, and I'll just execute one other curl command just to show that the API gateway doesn't have any reference to that. So we can see that there is no route matched with those values, which means the path which I'm trying to access here doesn't have any services configured with the conch right now. So next I'll go to the Postman collections now. So the first step is whenever rApp want to expose a certain API with the service provider, it needs to get registered with the service manager as a AEF and APF, which is a API exposing function and the API providing function. So the first API is, I'll just make sure that this runs. Yeah, it runs. So the first endpoint is to register the AEF and APF. This is a payload which I'm going to use here. So it contains the information required for that AEF and APF. So I'm registering it now. So we can see that it's created. and it provides the API provider function ID and the AEF function ID. So these IDs should be used whenever we try to expose the service API with a service manager. So the next step which I'm going to do is I'm going to create the service APIs with the service manager now. Here we can see that as we have created that AEF and APF already, we are using the references for that here, the APF ID as well as the AEF ID. And we are providing the interface description here, which should refer to some internal services which the API gateway is able to access, and the endpoint details. So here we have that what kind of operation the microservice exposes and the URA endpoints which the microservice exposes. So I'm going to create it now. So now we can see that it is created. Almost it gives the same response as what we have provided in the payload. The one significant difference we should notice here is the interface description. So instead of the internal endpoint, now the API gateway endpoint has been replaced here. So using this endpoint, whatever the services which we have exposed should be accessible. So that is about rApp trying to provide an endpoint there. So what happens when rApp try to consume an endpoint from the service manager? So for that, the rApp needs to get registered as an invoker. So that's what I'm going to do here right now. So it provides with a certain information, and it obviously needs to provide the AEF ID which it want to access, and all are the other API details here. So I'm going to register as an invoker now. So once it's registered, we should be able to see that the invoker ID, this should be used as an identifier for the discovery endpoints. So the service manager also offers the discovery endpoints here. So we can see that the API invoker ID is being used with this endpoint here. So with this API invoker ID, we should be able to query the service manager to get the list of endpoints. Here we can see that the API gateway is provided as an interface here, and all other APIs which we have created in the service manager is available here. So I'll go to the terminal once again just to show that this provider creation has been successful. So now we can see that the response is coming from the microservice. Earlier, when we have tried to access this one, the API gateway provided that there is no routes are available. Now the service manager registered with the Kong as well as with the microservice. It's created a route where the external user should be able to access the microservice which has been registered with the service manager. So over to you, John. Shall I run the slide from here?
Yeah.
Okay.
Actually, yeah. Switching up.
Yes, that's fine.
Yeah, that's good. Okay, so I realized, actually I skipped a slide. I was supposed to actually introduce what we were going to show. So just to summarize what you actually saw there was that the service manager implements the captive APIs entirely. So basically that's the discovery, the registration, and the ability to control access of what an rApp can see and what an rApp can access in the SMO. Okay? So that's defined in the 3GPP captive specifications. And the service manager also wraps an API gateway that ensures that we now have an enforcement point to ensure that the service exposure is actually controlled and managed in the way that we need. We also have a study running in the project of how you actually enforce that. We haven't integrated the enforcement yet, but we now have somewhere to do the enforcement in the API gateway now. Okay, right. So that was what we've seen already for the service manager. For the rApp manager, I just wanted to talk a little bit about what we think an rApp is. And we're still trying to land this concept, so we're not entirely there yet. But we see that an rApp is not just a microservice. The idea initially was that there's an assumption that, sure, we can implement all that logic in your rApp in a microservice, and then you just run it. Sure, how hard can it be? It's a little bit harder than that, because we see that an rApp is more of a composite bundle of stuff, okay? And I deliberately leave that vague, okay? So we think that an rApp can have 0 to n microservices. It can have 0 to n other rApp elements, okay? There's a function in OwnApp that helps us to lifecycle manage these compositions of apps, but mapping that to the idea of an rApp is something that we're focusing on in OSC. Okay? We also said then as well that rApps are unique in the fact that they control they have a controlled access to produce and consume data using the R1 DME, Data Management and Exposure family of specifications. And an rApp also has access to produce and consume services via the R1 SME, Service Management and Exposure family of specifications that are happening in Workgroup 2 in ORAN. Okay, so the rApp manager has to bring all this together. It has to onboard, lifecycle manage, and coordinate access to and from rApps. And it also has to set up and enforce data exposure and management, data exposure and service exposure to and from rApps. So it's a lot more than just running a microservice in your own cloud. So we are now going to, in a very similar way that we did before, show you some scrolling text that will hopefully give you the vague concept of what it is that we're trying to do. And then please come talk to us afterwards about what's actually happening. And I know we only have 2 minutes now, so this is going to have to be quick, Aravind.
Yeah, no problem at all. So I'll go to the setup part now. So again, a couple of...
You're on top.
Oh, right. Oh. Just a second.
Just end the show.
Okay, thank you. So again, I'll show up a couple of namespaces now just to show the containers which are running there. So this is just ONAP ACM components which are running. And similarly, I'm going to show a non-RTRIC namespace where the rApp manager, service manager, and its dependent components are running. So I'll go ahead and query a couple of endpoints again like what we did earlier. So here we can see that the root isn't available with the API gateway. rApp manager kind of integrates with the service manager as well. So the APIs which we are seeing here is almost similar to what we have seen in service manager. But here the rApp manager is going to do the deployment of the microservice as well, along with the service management configuration. So I'll go to that API part next. Second. I'll just close everything up. Yep. First, I'll query the rApp manager, what all the rApps it is having at the moment. So it doesn't have anything. So the next is to onboard rApp, where by providing rApp ID, we should be able to onboard, and with the rApp package, of course. I'm using a rApp package like this. Of course, we have a prototype structure of the rApp package at the moment. So yeah, it's created now. So once it's created, we should be able to query the rApp. So here we can see that these are the resources which is part of the rApp package, and these resources should be used whenever the rApp instance is getting created. So once after that, we are going to prime the rApp now. It is more like a step where it kind of indicates downstream components about this rApp, or if there is any prerequisite which needs to be done for that rApp, it is happening at that stage. And so once that is done, I'm querying this now. So now the status is changed to primed. Once the rApp state is changed to primed, we should be able to create the rApp instance. I'm going to create the rApp instance now. So where I'm mentioning a certain resource information which we can get from the rApp GET request. So it's created now. Once it's created, it is in undeployed state. And after that, similarly, we should be able to query the instance again. And I'm going to deploy the rApp instance now. Till the point of deployment, the rApp instance doesn't get propagated to the downstream components. And I'm going to deploy it right now. So now, just a second. It's successful, and I'll query this again. Yeah, it's in the deploying state. We'll go to the terminal again just to see what is happening in there. Now we can see that there is a microservice which has been deployed here 4 seconds ago, and that microservice is a Kubernetes deployment. After that, rApp manager is able to configure the service manager as well. So due to that service manager configuration, now we should be able to see the response for this curl request here. So we are getting a response for this, and I'll show up the query again just to see. Now the status has been changed to deployed. This is a procedure for the rApp deployment, and similarly we can go for the undeployed, delete, and depriming of the rApp, which deletes everything and removes the rApp from the rApp manager system. So that's all we want to show. Yeah, sure. Over to you, John.
Okay, I've been given the red sign to stop, which is fine by me. But please do come talk to us about what we're doing, the rest of what we're doing. I do want to leave you with a teaser here in bold that we're just this week announcing that we are hoping to get started on some topology and inventory service, SMOS, within OSC as well. Very interested in talking to anybody who wants to listen to it. Even if they don't want to listen to it, I'll talk to them anyway. So I do want to beat home the last point, though, is that we need your help. Everybody here, well, okay, except for that guy asleep, everybody else here is interested in SMO in terms of non-real-time RIC and in terms of ORAN. We need your help to try realise that in OSC. So please, row in, give us a hand. We need your help. Okay, thank you.